what is the last test going to be on?
Well, let's talk about it. You want to talk about it?
Yes.
All right, let's go talk about it. Do you have visual?
Yes, but I'm driving at the moment as well, though.
Okay, but I can still put the visual up for everybody else.
Okay.
So let me get to my Canvas stuff.
And we're on week 16, right?
Mm-hmm.
Okay.
I know, and I'm actually still need to do some more.
Is it lab today? Do
I
we
just
have lab
started
this
grading, so I'm
Do we have lab this week? Sorry, hold your point. Do we have lab this week, Monday or Wednesday?
We have in-person dissections both days. We have
Okay.
we're gonna do the kidneys this time.
Yeah,
And
no, I know. I remember. I just
I'm
wanted to make sure.
No, that's good. No, I'm glad you're asking that. So you asked about what is on the test, right?
The last test, the midterm
The
test.
last test.
Yes.
Yeah, so actually I did just rewrote my test review, but the test that you have is based on this one, which is a little bit smaller, but has a few mistakes in it. But I want to just go through it. So let me actually, hold on, before I do that, let me go back up. So what you do is, if you go to modules, you go to test 3 at the end here, and then in there you go to test review. And once you're in,
it's going to be on the respiratory system, right? The heart.
Oh yeah, but the heart too. But then once you're in the test review, you have the first tab shows us all the material other than the anatomy parts.
Okay,
like,
so I should look over the test
and,
review, right?
Say it again.
I should look over the test review, right? And that's gonna guide me through the midterm test.
Yes, but let me just briefly go through what's covered, if you want.
Okay.
As you're driving.
Okay, I'm actually listening to you. I can't. Sorry to cut you off, Ms. Professor. But I'm actually listening to you. I can't actually see the visual until I see it on YouTube. I'm driving right now, like I said.
No, that's okay.
So
but I can still pull it up and talk about it as we talk, and you're just listening. But what is on this document that is up right now is all the stuff that is not on the labeling exercises, right? And so what we're covering, we're starting at the heart, okay, in the final exam. So the final exam will cover physiology things like what we talk about other than anatomy terms in about 25, 30 questions. And then the rest of the questions will be from the anatomy term list. Okay?
Okay.
And in the anatomy term list. Go ahead.
Second term list, right? The second term list, right?
Yes, the second term list. And it's going to be a multiple choice. It's not going to be like the second test where you have to fill in the blank. It's going to be multiple choice also for the terms, not just for the. So it should be, and it's of course open book. So it should be a little bit more user friendly than the second test in that respect. And then, so it's these two parts to it, kind of. And so the first part is this stuff that we talk about other than the terms. And so in the heart, we're going to talk about, and on the review, I have all the bullet points listed out that I want you to know for the test. So ideally, you print that out or you have it next to you while you take the test. But even better, you actually go through that before the test and you make sure you understand all those points. And like in the heart, it talks about the EKG tracing. And so it talks about the different tracing. It talks about a few terms like systole, diastole, what are the heart sounds mean, but it spells everything out on the review. It tells you on there. And then in the test, you're applying that information. So basically, in the videos and all that, you learn that information, and now we condense it on that review, and then you apply that information onto the test. Okay. And so blood vessel. Yeah, go ahead.
Cut you off, Mr. M. We're talking about the bullet points that you're showing online, right?
Yes,
right now?
correct. I'm
Okay.
showing them online. And so we
Okay.
go through the different chapters. We go through the heart, how the heart works. We go through blood vessels. We have a few points there, but it's not too many. And it's all spelled out. It talks, for example, about arteries lead away from the heart, veins lead to it. And then there is a question somewhere saying like true or false, veins lead to the heart, and you say true, you know, that kind of way of doing it. And from there it goes to the blood, and then we cover also the immune system and the endocrine system and the skin, all of them. And then that's on page, what is that, on page 1 and 2-ish. And then from there we go into the nervous system. And so then we talk a little bit about the fundamentals, like you want to know that the brain and the spinal cord is sort of the computer part, is the central nervous system, and the peripheral nervous system is the cables coming out of them and go to the organs and the muscles. That's one thing I want you to know. And I also want you to know, for example, in the nervous system fundamentals, that a receptor in the skin, for example, detects something like heat and sends an impulse to the brain and the spinal cord. And then that's called a sensory impulse. And in then the central nervous system in the brain and the spinal cord, we integrate the information. And from there, you have a motor impulse going out from the brain and the spinal cord to the extremity again, or to wherever the effector is. That's a muscle or a gland, most likely. And that's sort of the loop, how the nervous system works. Information in, processing, information back out. So
Okay.
you know, let's say you're putting your hand on a stove and it's hot and it burns and it gives you a heat sensor, and the brain goes an impulse in, the sensory impulse into the brain is like, oh my God, let's pull this away. But then the processing happens up here, and then the pull away means you have a motor output going from the brain out to a muscle that then
I have a
pulls
question.
away, right? And so that's sort of the fundamental function of the nervous system.
Can you hear me?
Yes.
So, does the sympulse, sorry, I'm probably pronouncing it wrong. Does the nervous sympulse also control, since it controls the warm heat or warm temperature, does it also control the cold temperature and the warm temperature? Because I know that your body is always like room temperature. So does it control the cold temperature as well? Like if I was to go into Tahoe?
Yeah, the heat sensors also will read the external temperature and then respond back to the muscles or glands what to do. You could be sweating to adapt to it, or you be shivering, depending.
Okay, no, I just wanted to make a perfect understanding, just in case a person thought that it was just for warm or hot, not for cold or neutral.
Yeah, it also, the same system works for pressure or pain, or like all of the nervous system works sort of fundamentally that way. And
okay, that makes perfectly sense. So basically, if I was to like hit my hand softly in between the doorknob, compared to if I was to hit my hand hardly against the doorknob, I'm still gonna get the same reaction. Just like when a child have a sore on their leg and then they don't notice the sore until they look at it.
Mm-hmm. Yeah, or I mean, you have nervous system sensors even on the hairs on your skin, or even on the hair actually too. But if you like slowly get to a wall and start touching it, your senses on the hair will pick up that and send impulses already to the brain that there is something happening. And then when you bang into the door and it hurts, then the pain sensor will kick in as well, for example. And then they also send information into the brain and spinal cord to figure out.
Okay, that makes perfect sense. Just like when you're in a hot area and you start sweating, versus to when you're in a cold area and you get cold pox.
Yes.
Or goosebumps.
Yes. and that's the fundamental way of the nervous system works. The one where you touch your stove, it's too hot and you pull away. That's just called a reflex. You know, that's just a strong reaction, but it happens throughout. It could be you're petting your dog or so, and that picks up pressure, or your child, or you're softly touching something, or even then deeply touching something. Those are different.
So even being relaxed. So since your nerve systems are at room temperature, even being relaxed could trigger the nerve system.
Oh yeah, it's not just temperature, it's pressure, it's pain, it's temperature, it's deep pressure, superficial pressure, it's pain.
Yeah.
Even the proprioception, which is the position sensors, like telling the brain where you are in space, where your body is in space. Those are mostly actually in the muscles and in the joints, but those also send information into the nervous system to tell its thing. There's a sensory. All of these are sensory inputs. And they work the same with the visual, the seeing, the hearing. That all works the same way. Those are all inputs into the brain, and the sort of the central nervous system, the computer, so to speak. And then a computer can make a decision what to do with that information, and then you get a motor output. That's the motor part, mostly because it goes a lot to muscles. I think that's where the term motor comes from. But then that's the reaction to that input, basically, the answer.
I have a question that's off topic, but on topic, because it has something to do with the muscles. It's the eye muscle. When you know how you can move your eyes left to right and up and down, but what about when you move them to like opposite, like when you move it like southwest, southeast? Like, what about when you move it? Because I feel strains on my eyes when I move it a direction that the muscle is not pulling, but like in between the muscle.
Like, you mean the muscle doesn't work synchronously?
Like say I'm looking say I'm looking up, right? But I'm not just looking up, I'm looking like east. I'm looking like east up. Like, I feel like it's
up to the corner or something.
Muscle on my eye.
Well, two things. I mean, one thing, do you move both muscles in the same direction, or one goes the other direction?
Most of the time I look left, right, up and down. But then when I like try to look left, but like up, it's like strain.
Well, the end range is going to be strained anyway.
Okay. So that's normal.
You're gonna strain the end range of the muscle. It also is very good to integrate. I mean, we have interesting psychological techniques even with muscle movements, eye muscle movements, or eye movements, basically. The other thing, of course, that strains.
I have another question about the eye.
And you don't go in the same direction, Yeah, what's the other thing?
I have another question that I've been thinking about. How is it that people could hear different stuff, but we all see the same thing? Because like the eye is like basically your vision of what you see. But if I was to ask another person, well, I know that other people see different stuff, but most of the time we all see the same thing compared to we all hear the same. Why is that?
So you're saying often you're saying that people see the same thing, but they don't necessarily hear the same thing?
Yes. Like 9 times out of 10, I could find somebody that see the same thing that happened as me. But if we was to do like telephone, 9 times out of 10, somebody messed up what I said to them. How is it that we all see the same thing when
but that's
superior?
There you gotta differentiate. When we get to the senses organ somewhere, I think we differentiate that in there, like between sensation and perception.
Yes.
Like you gotta make sure that the hearing is probably there, but the interpretation of what's going on is not, is different. And that has nothing to do with the sensory input coming into the brain. That's way after the sensory comes in.
So what's more superior, the eye or the ear?
Well, they're both equal. I mean, it's both input.
Right.
It depends. I mean, if you're
I know what you're saying. Because like if I I know, I hear what you're saying. Like if I if I couldn't smell better than I taste, then basically one of my senses is more. But okay, I get what you're saying. They're the same. It's just some people's work more than others. Just like arthritis.
Well, no, I mean, I think what you need to differentiate is the difference between perception and sensation, right? What
Yes.
the interpretation of what is being said. I mean, obviously, not everybody hears the same amount because we have hearing loss as we get older. We have people who are deaf. But if you think about you're making a higher hierarchy in the decision processing department, there is none. The body wants as much input as it can, and so the brain.
Right.
And so, for example, if you're blind, your devoted area of the brain that is devoted to touching, for example, and hearing is much bigger because it can take up the cortex in the back that doesn't need to be seeing. So it has more room to process more detailed information. So those people actually can sort of then see through their fingers or see through
that
their
makes so much sense.
So,
that reminds me of the story of the little girl who lost her eyesight and then she lost her hearing within the age of 2. I mean, like, yeah, within the age, I forgot her name. Does that make sense? So basically, if one's like, basically like they always say, if you can't see, then you can hear more. If you can't taste, then you can touch more. Like, okay, I get it. Okay, that makes sense.
Right.
That was just kind of hard because I'm like, I know that my eye has 4 different muscles attached to it, but what about if I look my eye like southwest or west east, like, because I feel it. Like I try to look my eye up, but then sideways at the same time, and then I feel like a strain in between it.
And range strains it. Yeah. But you know, the thing that that makes sense, right? And that feeds right into a very, very important neurological concept. It's called neuroplasticity. And because basically when I say, you know, if you can't hear, the hearing part of the brain can be used up by the seeing part of the brain can be used up by hearing parts if you don't need the eyes, and by touching parts. And so that means that the brain is very flexible to be able to mold and rewire, sort of physically rewire. And that's right where we talk about neuroplasticity, how neurons that fire together wire together. And that's right where the gratitude journal plays into making us more happy, because we stimulate the pathways more that give us these good feelings that we remember when we have a gratitude journal. And so that's fundamentally how the neurology works. And so if you understand that stuff fundamentally, and then we add on the action potential, which is the mechanism right here where he talks about how a nerve impulse gets happening, how we have ions on the cell membrane, and we have sodium ions that are a lot more concentrated on the outside than on the inside of the nerve cell, mostly the axon at that point, that part of the nerve cell, the extensions. And then when a nerve impulse happens, the sodium flows in because there's so much more outside. So all we need to do is open channels and all the sodium comes in, and sodium is a positively charged ion. And so we bring all this positive charge to the inside of the cell, and that change in the difference between outside and inside charge is what makes a nerve impulse. And so that's what I want you to understand as well.
When you say sodium, that is not salt.
Well,
sorry to cut you off. Hold your thought.
No, sodium, it is salt. It is the salt. It is salt that we talk salt is sodium chloride, salt, table salt. And so the sodium part is definitely from the salt, absolutely. And it is the part in the salt that we need to watch in the diet because it is used in the body so vastly, and it's so important that we have enough salt. But that's why when
sodium, that does not mean salt, right?
Inside the body, it is a part of the salt. It's
keep talking. I might lose some type of connection because I'm driving in the mountains and the woods.
No, that's okay.
Keep talking. I'm listening.
So sodium is definitely related to what we consider salt, but we could talk about that we did in the heart a little bit. And so we definitely picked that part up as well. But the sodium going into the cell changes that voltage. That voltage is the difference in how many ions, sort of how many charges are on the inside and the outside of the cell. And so we call that depolarization. And so that's a nerve impulse when that happens. And so we then need a stop the nerve impulse. So that starts a nerve impulse. We need to stop the nerve impulse. And that's then when sodium channels close and the sodium can't come in anymore. But instead we open channels for potassium, and potassium is much more concentrated on the inside of the membrane in the nerve cells.
Sorry,
and that
does sugar have anything to do with sodium?
Does what?
Sugar, sweets.
No, sugar is completely different. Sugar.
Okay. No, I had a feeling. I just wanted to clarify that because I know that we need sodium in our system.
Yeah. We also need sugar, but again, it's a matter of the amount, right? It's a thing. And the reason why we eat too much salt is because our body craves salt, because in the old days, so to speak, there wasn't enough salt in the environment. So we needed to figure out how to get enough into the body. But now we have plenty salt on our table. And so it's a problem because we eat too much of it, right? But the reason why the body has such a taste for salt is because we need it in the body so importantly. And it's the same for sugar. We need glucose. We just don't need all that empty glucose all the time. Does that make sense? I guess I lost you. But anyway, so the sodium channels close when the nerve impulse needs to stop. But now what we have is we have the inside. Sorry, it's very hard. I can't hear you really, Grisha, right now. But let me continue real quick. Just give me a second and restart talking, or whenever you feel like you have reception. But the sodium channels closing and the potassium channels opening will re-establish that nerve, that electrical change between the cell membrane, the inside and the outside of the cell. And so since potassium is so much more concentrated on the inside, when those channels open, and potassium is also positive, all the potassium will go outside of the cell, not the sodium, now the potassium.
Inside,
the same charge.
I understand people that have diabetes and certain types of diabetes. That makes perfect sense.
Hold on. And now I can hear you again clearly, but hold on. I was just finishing up a thought, and then I'll be right there, because I just want to say that process then of the potassium going out, that's called repolarization. So what we have in this nerve impulse, we bring sodium in, which is positive charge, to change that difference in charge across the cell membrane, which is what a nerve impulse is, that difference in charge. It's like you put your hand into the socket and it snaps you. That's that difference in charge. That's what that sodium does. And when that sodium stops, then a nerve impulse can stop, and we open potassium, and all that positive charge that came in with the sodium now can get back out of the cell through the potassium. And we call that then repolarization. And the sodium opening is called depolarization. So that's the nerve impulse, basically. That's about it. Now tell me what you want to say. I hope I can hear you still. Do you understand that? Okay, I think we lost her, but let's continue then on this. Because basically what we continue afterwards is talk about the neuroanatomy a little bit, and we got a few points on that. We talk about the neuron, the dendrite, the soma and the axon, and the afferent and efferent nerves that we already talked about, the sensory nerves and the motor nerves. And a lot of them are actually called also mixed, because they have both fibers in them when we talk about a nerve in the arm, for example. And then from there, we go into the sensory organs. We have a few points on the sensory organs, just a few highlights that I want you to know that are on the exam. And after the nerve system, we finish up with the respiratory system, and then the digestive system. And we have only a couple of points on the urinary system, which means basically what we're learning this week is not on the final exam or on the last test. It's just material we go through the quiz. So I don't have any questions on the embryology or on the reproductive system. Okay, so with that, I think I'm going to stop sharing. And since I've lost Grisha as well, and it's just the two of us, we're going to stop the session here. But I want to make sure that you reach out. I work in the background, trying to connect with you if you have outstanding things that I see, but also please connect with me and text me if there is things that if there's things that you want me to help you with, or if you're behind and you need some support in getting through the last couple of weeks here. But other than that, we'll call it a week. I would call it a day for sure. Hopefully I hear from you guys. Have a good one. Take care. Bye-bye.